take this a step further, look at the greatest common factor in factoring by grouping. So this one looks a little different, but what we do have here are two terms. The 5 times x plus y is all one term, because we then have the addition, and the 2x times x plus y is also all one term. And within this term we have two factors. The 5 is a factor, and the x plus y is a factor, because they're joined by multiplication. The 2x is a factor. Well, technically the 2 and the x plus y are all factors because they're joined by multiplication. So we have the two terms, and the two terms, you may have noticed, have a common factor. The x plus y and the x plus y is common to both of these. So because of that, we can then factor out, we can undistribute that x plus y, leaving behind the 5 plus 2x. The 5 plus 2x. And this is our factored form. And the result this time, rather than being a monomial times a binomial, is we have a binomial times a binomial. So factoring by grouping is a technique that's worth trying when you have no common factor and a polynomial has 4 terms. You may want to try taking out a common factor, and if you still have 4 terms, then doing factoring by grouping. So again, 4 terms, factoring by grouping is worth giving a try. So to do the factoring by grouping, we first notice we have no common factor. The 2 is common to 3 of the factors, but not to the first term. The y is a common factor to 3 of the terms, but not to the 4th term. So there's nothing common to all 4. What we're going to do, though, is group it into 2 pairs of the y cubed plus 6y squared as one pair, plus 4y plus 24. Now these parentheses are doing absolutely nothing mathematically. They're simply there to visually separate the 4 terms into 2 sets of 2 terms each. But once they are separated, we can see, looking at the first 2 terms here, we do have some common factors. We have a y cubed and a y squared, so we can factor out a y squared. That would leave behind a y, as y squared times y is y cubed, plus 6, as y squared times 6 is 6y squared. We'll bring down the addition sign that was already there, and then look at the second pair. With the 4 and the 24, 4 is a common factor, so we can factor out, undistribute the 4, and that leaves us with the y, as 4 times y is 4y, plus 6, as 4 times 6 is 24. And now looking at these, we can see we do have a common factor, the y plus 6. So we can undistribute out that y plus 6, that's common, and that leaves behind the y squared plus 4, the y squared plus 4, and we've now factored this into a binomial times a binomial. And probably worth doing a check here. So taking the check, because it's a binomial times a binomial, we have to FOIL it out. First, y times y squared would give us y cubed. Outside, y times 4 is 4y. Inside, we have 6 times y squared for 6y squared. And then taking the last term, 6 times 4 is 24. And then if we change the order around, swapping these two middle terms here, we have 6y squared plus 4y squared plus 24, which is what we started with. And so this is our factored form of the original 4-term polynomial we started with. It's factored because we have something times something else, a binomial times a binomial. Okay, let's try a couple more examples here. Again, we'll group with parentheses just to visually separate the 4 terms into 2 groups of 2 terms. And to make this a little easier, what I'm going to do, the subtract 3b squared is of course the same thing as plus negative 3b squared. So I can write this as plus negative 3b squared subtract 3. Looking at the first pair, I can see I've got an a squared common to both. So I'll factor out the a squared from the first pair. That leaves behind a b squared plus, what do I put in here? A squared times what is a squared? A squared times 1 is a squared. Taking a look at the next pair, I've got a negative 3 common. So factor out the negative 3. Negative 3 times b squared is negative 3b squared, and negative 3 times positive 1 is negative 3. And now you can see that we do have the common factor, the b squared plus 1. I can undistribute that out, and that leaves behind the a squared plus negative 3, or a squared subtract 3 looks a little nicer. Okay, why don't you try this next one, and I'll pause for a minute. All right, did we get the same result in that third example? The first pair, xy plus 5x, x is common, so factor the x out, leaving behind the y plus 5. On the second pair, a negative, so let's make it a negative 1 for ease. Notation is common, so we'll factor out the negative 1, leaving behind the y plus 5, as negative 1 times y is negative y, negative 1 times 5 is negative 5. Then we can see the y plus 5 is common. We can undistribute out that y plus 5, leaving behind the x plus negative 1, or x subtract 1 just looks a little neater for the notation. And again, we can check any of these by foiling back together. Y times x is xy. Y times negative 1 is subtract y. 5 times x. And 5 times negative 1. Which is the same as the original expression, just some of the terms are written in a different order. And a note here, for a final answer, there are actually two correct ways to write the answer, because multiplication is commutative, so the order of the factors doesn't matter. Y plus 5 times x subtract 1 could also be written as x subtract 1 times y plus 5. So the order of the factors does not matter. And an example of one that does not factor, by the way, if you just make up a polynomial off the top of your head, odds are it will not factor. Most of them don't. So taking the first pair here, let's see, we have an x cubed plus 3x squared, and the second pair plus a negative 5x subtract 5. So we have an x squared common in the first pair. That would leave behind an x plus 3. As x squared times x is x cubed, and x squared times 3 is 3x squared. Plus, and then we have a negative 5 common to both of these terms, leaving behind a positive x plus 1. Now the problem on this one, these are not a common factor. We don't have anything common, so we can't go any further. And so we say this is what we call a prime polynomial. It does not factor. And we stop. And this expression cannot be factored.